Time travel, an enduring and fascinating concept that is firmly ingrained into our collective conscience from a young age. Countless books, comics, cartoons, animations, games, television shows and films have explored the complexities and practicalities of time travel, each one providing their own unique twist on the idea. Time travel is to the genre of science fiction what superheroes are to comic books. But what if we were to examine this concept beyond the realm of fiction? Rather than a classical fictional trope, what if we were to explore time travel as a phenomenon that could actually be theoretically possible in the real world? By the way, don't forget to like, share and subscribe to this channel if you enjoy finding rational and logical explanations for some of the world's most perplexing theories, questions and mysteries. Whilst time travel may sound unbelievable, this doesn't necessarily mean that it can never happen. There are many instances where the impossible was only impossible simply because the scientific, technological and societal advances required for this possibility to occur hadn't happened yet. Researchers are constantly uncovering and discovering novel insights about the universe and the properties of time and matter, and it is through these insights that we can begin to explore time travel as a very real possibility. Time is constantly in motion, so from a technical standpoint, we're all traveling through time, subject to its laws and properties as we're moving through it. In these usual circumstances, however, we're traveling in unison with time and with everything around us at a speed of approximately 1 second per second. When we're discussing time travel, however, we're universally referring to traveling through time at a rate faster than 1 second per second. And as unbelievable as this may initially sound, science says that time travel is actually quite possible. When it comes to the possibility of time travel, one of the most significant breakthroughs in its conceptualization was uncovered by the renowned scientist Albert Einstein through his iconic explanation of how time works. This is known as the theory of relativity, according to which time and space are intricately woven together and directly influence and affect one another. Another aspect of the theory of relativity which is relevant to this discussion is Einstein's assertion that nothing in the universe can travel faster than the speed of light, and as an object comes ever closer to the speed of light, time begins to slow down. According to Einstein's theory, the 3 dimensions of space are linked to the 4th dimension of time in a system known as Spacetime, which continues to be the model that physicists use to explain the universe to this day. What's more, Albert Einstein also theorized that it should be possible to actually fold space-time, and by doing so create a shortcut between 2 particular destinations, no matter how far they may be from one another in space-time. This phenomenon is known as a wormhole, and it can be most effectively explained by visualizing a tunnel with 2 openings at either end, with each one emerging at different points in space-time. Remember, the existence of wormholes remains theoretical, but because of their consistency with Einstein's theory of relativity, which has been ascertained as true on a number of its assertions, there does seem to be a convincing argument for the existence of these structures. However, even if we were to eventually identify and locate wormholes, using them for time travel won't be a straightforward procedure. Firstly, the most obvious obstacle is that the nearest wormholes would be light years away from us, and we haven't even developed the technology to traverse these distances within any reasonable amount of time. If there was the slightest chance that we could identify and locate a wormhole, there's no way to guarantee or predict where or when we would be once we emerged from the other side. What's more, physicists estimate that wormholes are incredibly unstable structures which collapse frequently and sporadically. They may be the most likely contender for making time travel a reality, but it's going to require a feat of engineering of such magnitude that time travel will remain a theoretical likelihood for the foreseeable future. In conclusion, however, time travel is so much more than mere fantasy. Whilst the technicalities and mechanisms surrounding time travel are still obscure, it can be said with certainty that the possibility of it has not been ruled out by the laws and principles of physics. The very idea that there is nothing in the known laws of physics that would prevent time travel from actually happening is an exciting and thrilling prospect. We're passionate about creating content like this for those with an insatiable and endless appetite for learning and inquiry. So please subscribe to this channel for more captivating and inspiring content.